Hello and welcome to another evening of Rusty Bot Programming. And I'm looking a bit small on the screen. I can't even see myself. Don't really need to, but I'm going to fix the window there. Hopefully the camera's stable again today. What I'm hoping to do today is we're going to start the Monte-Carlo simulation. We're going to get to that in a bit. We're going to go and play, as usual, a Clash of Code first. Just to make it exciting, even though I don't know why I play these things. I mean, we might stop playing them at some point, but we'll see how far we go. If we do well, it motivates me to do more, but when we do poorly, not. Oh, it's reverse mode. 650. Well, this is a bit weird. Divided by 2, divided by 3, divided by 5. Divided by the number of digits in the string. So this string divided by the number of digits in it. That seems reasonable. Okay, so that should be pretty good. And they're parsing the input and... No, the guy's already done. Input line.trim. I'm going to parse the S then. And what we really want to do is we just want to print... We want to print n divided by s.len. I think that's the value. Wow, those guys are fast. I can't do it fast enough in Rust. Expected I64 found use size. That's fine. As I64. I wonder if these guys have played these before as well, or are they're actually really just that fast. So we get good. I'm motivated to do more in that case, but I'm only going to do one in the show. Just get to get me into the mood. And 21 seconds. I mean, you can recognize it that fast. And my mouse is working weird. Enter digits to I. I see this is where if you know the language well enough. Why? It has a .digits function? .count? Oh, that's really weird. You can also do a len 10, like a logarithm base 10. And the Python one's going to look about the same. Int n, okay, we have that one too. And in these dynamic languages, you have a bit more options, and so ours is a bit very similar. So I just trimmed the line first of all, and because I don't know, there probably is a function that says the number of digits in n. And number of digits is relatively easy to calculate. You generally just do like logarithm to the base 10, and you have to worry about the tricky sort of zero cases, but otherwise it would work. Alright, but let's move on. Let's move on to the actual... Let's find out what's with my mouse. There's some bit of plastic under it. Another broken CD bit, that's the issue. Alright, so now the mouse should work again. What we want to do today is we're playing the tic-tac-toe. We're in the Bronze League, of course, because we didn't actually implement a game player yet. And we're slowly going down, so there's a lot of people competing in the Bronze League, which is good to see, because we don't have a strategy, so we don't actually want to see us doing well. Turn that on, and we'll use the previously selected file. I'm going to upload the file, and now we're going to go to Visual Code. Visual. Okay. So what we had last time is where we were is we had an actual play game, right? And we could play a game. And this played a random game. So it's playing a random game tic-tac-toe, and it said, well, that was a tie game. Interesting. But we haven't implemented the final condition yet here. If it's a tie game, we actually have to count the number of individual boards to see who won. I don't think it'll come up often enough, or maybe it will. We'll have to eventually worry about it. So 0 ones, 1 wins. I don't call them X-Go. So tie actually... tie came up surprisingly often there. So when you play at random, you tend to get ties, which is really kind of weird. But I guess it kind of makes sense. So maybe we should put some condition here, tie. But before I work on that, what I wanted to do is in this state, I wanted to switch everything to start using linear indexes because the XY is getting to be a real pain in the ass. And so the board size here, the size. So by linear indexes, it's just going to simplify a lot of things. Board size and stuff, this is all fine. And get player at, we can change it, try to see what we can change here. because we have this linear representation anyways, and we have get player at, and this xy can remain. We're going to have a second get player, just going to be get player linear, and it's just going to call that one. We're going to do pub function get player linear and self, and this is just going to be a cell. It's going to be a use size. It's going to be what player is at that one there, and we're going to give it a good name in case you're looking at it. Cell. This one goes back up there. And we want to add cell. And cell. So we check all three players, otherwise it's not a non-player. And this one is just get player linear bit, which is actually cell as a self. So we're going to convert linear because this will simplify some of the formula somewhere. Set plays player, that's all of the plays, set player linear, and I'm going to use this just the lin abbreviation for all of this stuff. And I have no idea why set player lin called set player at. That's like totally backwards. So we do it the other way around. We're going to make linear the dominant mode, because this should simplify quite a bit. And if player is clear, that's fine. We clear the bit. Set player linear, we're going to call it cell. Not cell or equals cell. Clear them all, otherwise we set the player. And set player at becomes set player lin self dot. This becomes bit comma player. And next free, and this is where the next free stuff's going to change. And this is where it gets simpler here, is that we don't want these to return a combination. We're just going to say next free. And here we just return I. And it removes a lot of calculations. And for speed-wise, it's going to help slightly, I suppose. Maybe not. And we combine them all together. And oops, bold full. We should never get here. Nothing to call it. Random free is also just going to return use size. And down here, we can simply return the index now. It simplifies calculation. There's a few places that will have to do it, but not so many. Board state, board state. The rest should probably be take turn. Let's make this linear as well. So this becomes simplified cell, two values, and then whoever's taking turns will have to convert that on their own. Set player lin becomes cell player. Okay, where are we? So again, the SB is the small board and the big board, and get player linear is going to just be this. So we can simplify a lot of stuff. And this is actually going to help. Get board index. Board index cell. What did I want to change here? Not XY, we already have a cell. So yeah, just cell. We already have this cell, get board index XY, so we have the cell to start with, don't even need spaces there. Okay, and too bad RLS isn't working because we'd see all the errors right away, but now we don't. But we must have tests somewhere. That's going to fail on us. Entry is going to fail as well. So take turn, we're going to have to convert this. So we had a function called get board index, and I'm going to change get board cell now. Just going to use a common name, get board cell, get board index, not there. Get board cell, this is just times board times as use size. Guess we don't need the as use size anymore because this is all use sized. Get board index, and this will be get board cell, and this will also be get board cell state.board get board cell. And I'm going to make these not be part of the state function actually, because this is pretty common, and as we know in Rust, we don't want to borrow stuff if we don't have to. So we'll put it up here because it's not dependent on the state public function get board cell, and it just ignores cell that. So now we can just do get board cell Get board cell opponent as U size, comma as U size. And that should be enough. Opponent row is actually I32, so that makes sense. Probably reduce this here too to one line. Okay. So a turn is comprised of two cells, the big board cell and the small board cell. And that's what we're converting in entry here. We're converting from the big board to the small board cell. And we also have it down here. This get best move is now going to return a cell. Take turn cell. An ePrint line. Well, you know, ePrint line or debugging, we might want to... Yeah, you know where for the consistent that works. Just remove it for now. Okay. And now the tricky thing here is now we have this more complicated conversion because of the fact that their board is considered a 9x9 grid and we have two cells, which are totally wrong. So it's going to be S board, so it's going to be... What's this actually going to be? Cell divided by 3 plus cell mod 3, and that determines the small cells, and this is the big cell. So we should be fine there. Big board print. We print the boards each time. And let's open up the test case because that's going to fail us as well. Lots of little bits to change. I think set player at. Set player at should be fine. That should actually be fine. Tic-tac-toe source is bin now. We want play function should be fine. Yeah, now this has a cell as well. Cell. Take turn cell. Okay, and there's one more thing. Strategy, I guess. Get best move is going to return just one U size now, not two. Let's cell. And next free is just going to return cell, so I can actually just do cell equals. Cell equals. SBX comma cell, and I have to check the next free if it actually does that. Get random moves, just returns 2. So this is where it simplifies stuff here, is if we just ignore the fact the board's a grid for most of this strategy, it really just simplifies the indexing. Because we're going to have a lot of little arrays and vectors as well, and it's just easier not to have indexes, XY indexing anymore. This is cell, cell, and let's check what next free returns. Next free returns a U size, that's correct, and random free also returns a U size. So we should be good. Cargo check, clear and cargo check. Alright, we got a few errors here, not a big deal. Entry line 41. Get board cell. This needs to have an extra bracket. And that's probably what most of the errors are about. Let's just check that again. Oh, get player Lin 107. 107. Get player Lin returns. There's an extra bracket I forgot to get rid of there, and that probably screws that up enough there. Oop, now I have more errors. Now let's get the real errors. Expected U16 found use size. Well, this is where it's going to find this be annoying. State RS 132. Well, that's the test case. Cephal, not a cephal. 109. And so now it's going to want a U16 everywhere. We return to U size, and a bit off because it's U16, so we can safely just do as U16, because if it's not, then we're just in trouble anyways. This is also going to have to be as U16. I don't know how many places I'm going to have to change. 123. Let's use 16. And we're out externally. We're just going to keep the U size. There's no value in actually trying to make it externally know about the internal size implementation. It's 123. What are we? 126 and 44. And 206. Player Lin. I just call these Lin for simplicity. Remove these parentheses. I actually don't like this warning. So honestly, I'm going to remove this one because I don't think it's a productive warning. I'm not clear on what it's trying to capture. Like, what air condition is that actually trying to prevent? I mean, if your language distinguishes between unnecessary parentheses and not parentheses, then you have a serious problem, but I don't think it does, so I don't understand what it's trying to catch. And in that case there, that was one of a consistency too. And you'll often see patterns like that where it'd be a little bit weird to have this one in parens and this one not in parens, and sometimes so it's just easier to just ignore the warning because it's not being productive for us. I mean, so far it's not condict one thing, so let's cell equal. I'll just do this one here. SBX. And this move, this is going to change. Get best move. This is really just get next move. I don't know if we'll retain that at all, but and this is actually cell. SBX is. Well, and apparently my not warning here didn't help. What's this? Link level defined here. Would I put a not in front of it? Oh, I had to do allow. Good allows. And I'll go test, I guess, as I wanted. Okay, so there's the cargo test. Man, I really should. Oh, this does say little tests up there, so it's actually I don't have to give the names differently. Take turn. We could try to figure out what cell this is. So we just say 5. We don't really care. Uh-oh, something failed. Test turns. Maybe taking 5 wasn't the best idea. 1 is 0, 1, 2, 0, 1, 2, 3, 4, and 4. It's 4 and 4. That's why it didn't work. Oh, come on. S board takes 0, 1. Small board 4. That's the first board. That's the board in the top left. And the fourth one's directly in the center. Okay. I'm set all the places the small board. Then we take the turn. And what were here before? Did I get the turns wrong before? 1, 1. Well, we can just do this. We can do get board cell to be clear. And that would be the direct conversion. Although in positive that returns 5. Alright, so something goes wrong there. Good thing we have these tests. Take turn. What is take turn doing wrong? Take turn. Use size cell. So this is a small board. We split that. We get the state if it's open. If it's win, we get set player linear. Cell should work. cell. If it's the same clear, then they take the cell. Otherwise, board index none. So this function, it returns what the next player, where they have to play. And so the first thing we do is set player linear, cell player. That's fine. You know, maybe it should be player comma cell, to be honest. Because the name says player lin, it should be player comma cell, but... And get player linear as cell. It was just because it was called set player at before, that it had the first index first. Small. Get player state. Open. Win. Well, I'm not certain what's failed now. Where's it actually panicking? $58. Q, take turn, 1, and the next player has to be, and this is cell 4. And we already set the board, small board at 4, so it's taking a turn for 4. And we set these values here. And it's supposed to be none because that actually gets the win for that board. You would put the value right in the middle. And that would mean that this player wins the board, so the next player should have an open board because there's nowhere left to play there. And instead he got 4, so okay, something wrong there. Cell 4, so at least recognize the cell, but why is it wrong now? What happened now? Set player lin somehow wrong. Or equals cell, that should be fine. And 1 greater than board size plus X, that should be fine as well. Is this bit correct? This bit seems weird. This is really supposed to be this, isn't it? Shouldn't make a difference in this code, but still the same thing. But nothing's calling these ones where I had that thing there anyways, so it shouldn't make a difference. But this should definitely be this. Uh-oh. Where's our error? Set plays, player U size equals S, that's fine, U16. And our test says it's Q. Why is it Q? Well, let's do a dump there. Let's see what we actually have then. We have S dot print. And it's going to cargo test dash no capture. S dot board dot print. Alright, so what do we have? We have, ooh, it's put it in the wrong spot. So it's got the right board, but it's stuck it in the, oh no, it's just, and it's now really kind of pissing me off. Take turns so we can clear it. So we take turn at 0, 1 board here, and get board cell 1, 1, which is clearly wrong. It should be here in the middle. We could do this first for sanity. Assert equals 4. Get board cell 1, 1. Now let's make sure that works, that those are returning the right values. Now we can see what the issue is there. Alright, so it's getting the right one, but take turn is clearly doing something wrong. Take turn. Because it should be saying that it takes player 0 in big cell 1 and little cell 4. So take turn, player, big cell, little cell. And it does set player at. Set player lin. Set player lin appears wrong. Oh shit, I know why. Wow, no, I screwed this up. Wow, I have to be very careful of that. The bit is cell. And this is not bit. Or equals bits. This is correct. And this is actually this part here. So that was clear. The conversion back and forth, but be very careful, is that the cell is not the bit we're setting. The cell is the index, but the actual bit in the bitmap is something else. This one's here is correct. The cell, and I'm going to double check all of these random 3. Index is fine. And we had another one, get player at. Get player. Oh, it's right there. One cell. And this becomes this. Good thing we had test cases this time. I don't know. What's it complaining about now? 132. No, where did he get that from? I replaced the wrong bit. Unused variable bit. That would obviously be an error. 107. And bit equals bit. So my viewers are rather quiet today. That's okay. We'll just go through this normally. Alright, so that all works. And so we do clear and cargo build, cargo dash run play. Make sure that still works. Let's do cargo build. I don't remember the options to do this stuff. Target / debug display. One wins. Okay, so we have that again. So git status, git commit, change to linear indexing. All right, and that should simplify the strategy. Because the next step now is we can actually work on the strategy. Get rid of this test case. Get rid of the lib, I think. Get rid of whatever main is from another program. Cargo Tama we don't need to look at very much. Play, we might want to go back to the play, get random move. And this is now get next move. And these all have the same interface because these are all basically the same function. You just want to determine which one to call. Okay, now because of the big board small board split, this gets a little bit more difficult to set up. Because if we take next free, the big board one is going to have a different starting point than the small board one. So basically you have 2 different top level functions because you have 2 different moves, and we do not want to have like a list of possible turns because it'll be slow. We need to be able to play the game entirely from one position. So given certain positions, and what we can do is we can make this slightly more costly. To simplify, first of all, we can, when we're doing like an open move, we can call get best move and all of those open ones, but that's going to be horribly slow, but I don't think we have that much of an option because that'll just be hard to say where the recursion happens there. But we simplify it first, and that just means those moves are a lot more expensive. Okay, let's just do it that way then, though. Board index is none, so we're going to iterate through the free cells then. And I'm not sure, how do we iterate over the free cells? Well, we just have the index between the 0 boards. And how can I do that? Oh man, I'm getting really... So we really need to get a score for each one, get best move for each one, because we need to get a... Yeah, this split makes it really annoying because I don't know where to start, because we have 2 different tree types, and that's kind of annoying because you have 9 moves and then 9 moves, so it's like the player has 2 sort of steps. They have a potential 81 moves, but you only have 9 in most cases. So how do we want to do that? Trying to think of... And this makes it a little bit more annoying to start. Or do we do the full array, or do we convert the small one into just a list of big ones? That's an option. Let's do it the costly way first. We treat all of the moves, even the cell ones, as basically being open, but then we close them all off, because we're going to have them all closed off anyways. And so we're going to say let mut, or let's open use 16. And open, in this case, open equals 1 SB. And that's the only one that's open in this case. And then we convert them all to the same thing. And open now equals to, we need a state to get open cells. The board needs to have a function that says get open. Public function get open, and let's say mask, because this is what it really is, to use 16. And it's actually not get open, it's get closed. So we're going to turn all the ones that are closed, actually, not the ones that are open, get closed mask. And so because we have a fixed one here, what we actually have is we have open equals state.big.getClosed mask. And we can actually do it this way, let open use 16 equal match 4, so just return them directly. Simplify that. This is perhaps not a very clean way to do this. It's going to be inefficient, but I'm just trying to merge it for now. So what open represents, these are all the spots that we can take up to the number of board counts. And we're going to confirm all of them. We can do a just count for all of them, I guess. And now we need a score for each of them. Yeah, I know this is stupid though, because if it's just the one cell one, I know we're gonna need scores for both of them anyways. Regardless of which one we have, we're gonna need to have a potential best score for each of them. Man, I hate setting up this recursion. Setting up this baseline recursion for these tree walking is always annoying. It's always annoying. So, but what we need is we're going to need some sort of score. And that score equals, this is a vector of, I don't know, let's start them at minus whatever. We need a sufficient negative infinite value, I guess. Oh, it doesn't matter, let's just do this with 0 and board num cells. And this is a score of I-32 should be fine for that, I think. And then we'll sort through them at the end. What now we need to do for I in 0 dot dot board num cells, we need some sort of implementation that sets the score. So if open and I, or 1 and I, then we score it. Score equals dot dot dot. Then we have to find the max of this, but this has to have more score cells than this. This has to have a little structure of the score and the move to actually take. So this is actually a, man, how do you do this? 0, 0 use size, 0 use size. It's comprised of two boards, and then we're going to have to return the max of this, and max by, I guess, score.iter.max by key, I think it's what it's called, maybe, item.0. And now we have to unwrap this somehow. Well, let's just do it this way. Let's score, comma, SB, comma, cell equal. Then we want to return, I gotta fix that, SB, comma, cell. And we return SB, comma, cell. So we're going to go through each of these board types, and if there's only one, and this is where it's like we can optimize this later. If there's only one, we can simplify this later. But I just wanted one loop now to get an idea of what the generic structure actually is, because we're going to hit this quite often when we go through the game, and we're actually going to have a tree that combines this. And so now what we need to do is more of a get best move score, and this will take the state. And it takes the big cell. Well, it takes it for player, of course. And I have no idea why I put an underscore on player, because I wasn't using it. Okay. Player, and it takes the big board. Just the big board. Yeah. Now we need the function pub function get best move score, which takes the state and board state. Player is a use size. I don't know if we'll use this yet. And SB is the big cell. Use size is the big cell, and this returns a use size. This returns an I32 for the score. I32 use size, use size. Okay, so now we have the basic. Now we have these scores here for each board state. Now on the small board we have the same basic things. We have the open cells, and we want to keep track of wins and losses and counts on each of those. So what we need to do is we need to do let tree, we'll just say this. And this is only a one level tree right now. And we need to keep track of for each, well, this is cell. The first score is the number of wins minus number of losses. And the second score is the actual count, the number of times we've done this thing. Board num cells. Okay, and for each board location, let's just iterate, let's commonly go over all of them. Let's give an equal fair share to each of them. And we need to have an open here as well. Let open equal date.small sb.get closed mask. I don't know why I keep calling it open. This is closed. Closed. And this is if not closed. That would have maybe, that's maybe why I did it if it's not closed. And we do again here, i.board. So we're going to operate over all the cells. So for clarity, this best move, this base move one here, it sets up the loop for saying over what are the big cells am I going. So if I have one cell I have to go to, it picks that one. Otherwise it gives all the big cells where I could possibly go. And that's just a clash of code there. And then the small one says, in this particular one, for all the ones that are still open, then I'm actually going to score them. and you keep track of scores for them. So each all the board cells, and we're going to say if closed here, just continue. If closed, just go on your merry way. Otherwise, now we actually have to run a simulation of the game, and so we have to calculate the whole sort of game logic at this point. And we should have done this from the play code. This play code should be more common. The play code should be looking at strategy and say, hey, look, you know, run a game. Run a game from the current state you're in. So let's see what that would take. What would the game state be? We're going to say play a game. We're going to let it play to the absolute end. And I'm going to put this in strategy. And they're going to make it public because the play can also use a public function play to end. We ... What does it take? What does it return? We know it returns a game result, but let's put it this way first. It returns a game result, says who wins, what wins. And we need to have the state. And I'll make this one take an immutable state. And it needs to have current player. Who's the current player? Use size. And where they're forced to play. Right, so yeah, where they're forced to play. Forced, board index, that's fine. Where are these people forced to play? And this plays a full game. And this starts at current player, wherever the current player is. Force equals board index none, so force equals force. And we'll take current force just to keep this simplified. Current force. And state.board, the get state. Go away. And so we're going to do one thing. Game result open is the one case we're not going to do anything with, because the other cases we're going to do a return R. Because those are the cases that basically when we found the end, then that's where return R and that game is over. Otherwise, we say let SB cells get random move, and this is actually random moves now. We want random moves at this point. And state.board player force. Make them take a move, and then the state takes a turn, but we need to actually do a dupe state here. Let mut dupe state equals state.clone, because we don't want to modify the original game. Fortunately in this game, this cloning is basically free. It's like a bit of like 8 bytes or something, or maybe 12, 16 bytes. Unlike a lot of other games, the duplication here is virtually free, so we don't have to worry about that. The cost here is virtually 0 compared to like this random move stuff. Take turn player that. Okay, so this plays the game to the end, and to make sure this is working, and where's this get best move here right now? Oh, to make sure this is working, we're going to make play work with this first. So we have play to end, and play can actually do that. Play can play to the end. Let result equal play to the end. Play to end on S, and it's not going to touch this state, which is kind of shitty for this mutable here. So let's actually make play to end take a mutable state, because otherwise play doesn't work. And we'll just do this way, muts, and then the caller can do clone if they want. Let the caller clone this stuff. So they play to end current, and the current player is 0. Board index none. There's no force, so this sets up the return, and this plays the whole game. Then we can do match on result. Match tie game, and this is technically not a tie, but we'll worry about that later. And if it hits this bad one in the back here, we're going to say print line something bad. These don't need breaks, of course, because there's no breaking from a loop. There's just a loop, and then we print the board at the very end. And actually, we should probably print this before we print out the winners. And actually, we need a separator between those two anyway, so let's just stick it out that way. Let's see if that gets us something. Clear and cargo build. And I know there's a run function. We're just going to do targets debug play. Alright, where are we now? Unexpected token. Unexpected token at line 38. Why do we have an unexpected token? Because we have something opened up here. Or maybe not. I don't see anything open. Well, let's check the other ones first, see if there's nothing enclosed and... Yeah, I forgot to call it closed. And this is going to need a return. We're not calling this one yet, but let's just give it a return. 0, 0, 0. Alright, and this is, yeah, state.big. Probably should have called it just board and state. Get random move. Yeah, okay. Alright, so I still have something there. Expected bool, line 31. Or we just do, okay, it's not if closed. 0. We're good to go. I'm ignoring that one. Expected because of return type. Expected tuple, found nothing. And this is line 23. Wait a second. It's got a return value right here. Oh, because there's 2 right there. I'll be doing leaf programming all day. Don't need semicolons. Get closed mask. Alright, 44. Which is not equal 0. If it's not 0. Alright, so now I can figure out what this is. Expected enum option found tuple. Yes. It apparently Max can't figure out the fact that there's no possibility that that's going to be not 0. Okay. I hate working with these sometimes. The references are kind of annoying. So we don't need the score. We need to leave it for now, unused. Cannot assign to index score content of immutable binding. Oh, I screwed that up. That has to be a mut score. Alright, what do we have here? What's this problem now? Line 8. State.board, I guess. You can have that. Alright, so that actually worked. Target/debug/play. 1 doesn't seem to want to win anymore. There we go. Just want to see it once. It's quite random, so we're good at that. Again, the likelihood of tie is not very good, but for the initial round, we're just going to ignore that in our evaluation. And we'll see as we go on whether that's actually how relevant that actually is. So it plays to the end of the game. That's good enough. We have play doing that. Plays to the end. So we can close that. We don't need that. Now the get best move. This is a part we actually have to figure out doing it. We're going to do a play to end. And what we want to do is we want to say let R equal play to end, state.clone, and I know, we're going to do it up here. Let S equal state.clone. We're going to do let force equal state.takeTurn. Player is going to be this player, and SB is going to be SB, and cell is going to be I. So we play this player's turn. And now we need to say that play to the end for the next player. Play to the end is going to be S. It can take S all at once. This is mut S. And mut S. And play to the end was current player and current force. And this will be player plus 1 mod 2. I just hard code that for now. And the forced. And this will play to the end of the game and give us a result. So the actual scoring takes place right now. The current score, let CS equal to tree I. CS.1, I'm going to say mut plus equals 1. This is the number of games that are played. Number of games played. And now we're going to do a match on the result. Match the result is going to be CS.0 plus equals match result, game result, win player is going to be player equals player. I'm going to do this. If it's our player, then we get a 1, else we get a -1. That's a loss then. Game results. Open, well, everything else, because we don't want to skip the 1, doesn't modify the score one way or the other. We're not going to value ties as anything good, but the count will actually go up. So this goes through and it runs through a whole bunch of simulations and it says who won, what was the result, how did this win. And we can do a print line here just the first time to actually see, well, what are the results of this thing running here. And CS, I guess no, R. This is going to run thousands upon thousands of times. And so now we've run through, we've only run through once, right? We've run 9 of them. And we're going to do iter in 0. It doesn't actually matter what this is called. And actually, we probably shouldn't. We'll print it out one time. ... 10. We're going to print out 10. So we're going to run through each. For each cell on the board, we're going to do 10 random playthroughs. And the random playthroughs, and we're going to base the count based on that. And now we have to figure out what the best playthrough is. Or actually, the best scoring is. The best scores, and we need to find the best index. So we have a score, usize, usize. Why does it return 2? SB and cell. We don't really have to do that because we already know the SB, but that's okay. Okay, so we have to do, and whatever's inside here, this is the score, and this is the, we don't need the second part. But I need to map this. I need to have the enumerator. Oh, how am I going to do this quickly? I'm going to enumerate, which then has the key and value packed together. Because we're going to ignore the number of games played at the moment. I'm just trying to figure out how to get this put together. And this is the cell. This is going to be score. We're going to simplify this. Equals tree.enumerate. No, let's just do it map first. Map. And we'll just take the first one, t.0. We don't care about the thing. Then we're going to do enumerate. Then we're going to do a max by key. T again. T.1, because the first one's the enumeration and the next one's that. And done in rapid because we know there's one there. So we have a cell and a score. And what do we return? We return an I32 for the score. So score. And the SB is just the input we have. We're just mirroring that back out. And then the cell. And so this should give us the best move. Let's just see if this actually works. Clear and cargo check. Trying to how to incorporate this into the test play. Unexpected token 58. Now there's supposed to be that. This will be a tree.iter.map. Expected tuple found reference. Oh god, I hate this. Max by key was supposed to return. Where is that? 50? Get best move score. Okay, we shouldn't have, it should be s.take turn. So that legitimately caught the correct thing. Now what I'm totally unsure of is why is there no and here, but there's an and up here. I really don't understand this. These are both like vectors, fixed length vectors. I did a map on the one, and I really don't understand why one requires a reference and one doesn't. This is kind of weird, and it's something I can't figure out. It's I understand pointers and stuff in C, but the references here, and it's the problem that there's something, some of these things here convert references to non-references and non-references to references, and that's where I get confused because I can't tell by looking at the code which is doing which. So now we have no way of testing this locally though, because nothing calls the best move. Unless we just do it up here. Play to the end again. No, we can't do play to the end because play to end. I'm trying to think of how we actually test this now other than just submitting it. I want to see it run at least once first, and well, hell, let's just submit it once. Not submit it, I mean just play it once against the boss. And its output's going to be clipped because we do way too much of it. And we do something wrong here, I guess. We probably just timed out or something. Invalid output. That's why I want to test it locally. But let's see, this is output here. Win, 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 close, win one. So it looks like it's actually executing games. Close, 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 close. There's tie games. It looks like it's executing games. And executing a lot of games, which is what we want. Let's take out the print line and see what happens then. Let's see if it was just because I was taking too long, which is... Alright, I'm doing something wacky. That'd be 8, 8. Okay, so I got something wrong here. It's outputting 8, 8 again. What did I do first? The standard airstream, and then I said 8, 8. I played 8, 8. Good. 8, 8. And then he played 6, 7. Yeah, because it's row for 6, 6,7. That's still confusing. And then I did 8-8. Why the hell did I do 8-8? Did I forget to track my move? Print that out. I take the turn. Well, no, I do track the best move. And then I print out the board. It's right here. The board is X. That's correct. Who knows why I took that one at random. And then 6-7, we got that. Then does 8-8 again. That's weird. 8-8 is occupied. It should be playing this board up here as well. It's not allowed to play it on there. So I got something screwy here. What's actually wrong here? Let's print this out. E-print line. Where is it forcing us to? SB index. Maybe it's the wrong one. Cargo build. This is why, but I don't have the input testing there anyways. Cell 1, so it's forcing the right board. It's forcing it to that position. And it's choosing the wrong one. So it is forcing the right position. What is get best move doing wrong? Get best move. This is why I really wanted to test it locally, but I'm not clear on how I can actually do that locally. Board index. So if it's none, it gets closed mask. Otherwise, it shit. This is opposite because this is returning closed, and this is returning open. Well then, we could just do this. That becomes closed. Let's try playing that. Oh, come on. Now what is it doing wrong? None. Output 8-8 in cell 2. Just over there. And I played up there, though, which is the wrong place. So I still got something wrong there. It's still playing in the wrong damn place. It was told to play in cell 2. I want the inverse of that. Everything but that one. That's the one that's supposed to be open. Which is really weird. Why is it? It's choosing the wrong one. Let's see what that looks like. Anybody know how you can print out binary in Rust? Rust, print binary number. B, good. E print line closed is B closed. That's the closed board. It's all of them except that one from the force. From the force. And SB has to stay the same. SB Item.0 is the score. Oh, right, we need a filter here because it's picking stuff. I forgot to filter it out. That's why I say you can put a really, really low negative score here by default. And that would work as well, but I don't know how high that number has to be. Is there like a negative infinity? Lowest rust, lowest integer. That's what I really want, lowest integer. Just to exclude them so I don't have to do an additional filter. I'm getting a little zeal here. No, I don't want the newest version. Stop asking. Rust i32. Min value. i32 min value is what I want. So if we don't set it in this loop, it's going to have the minimum value and it's not going to pick that then. Now it's going to give me errors, of course. It's going to be ePrint line. I did. I think that's the error, but I'll still do the ePrint line just in case. Get recipe score player. Found i32. Expected function. What the hell is it expecting? Oh, yeah. That's weird. It's weird that min value is a function. You'd really expect min value to be a constant. I have no idea why it's a function. We need somebody in Rust to explain that to us. We need rusty people. This should take a long time because we take... And... Did we do something wrong, or... Invalid action again. Come on, what are we doing wrong? So it said cell 7. This is 0, 1, 2, 3... Yeah, that's cell 7, the 8th item, because 0 was the first one. So that's the cell item, so we play closed. This is closed, so we're going to play in... eight, which is down here. 0, 1, 2, 3, 4, 5, 6, 7, 8. Actually, 8's down here, 5. That's a legitimate move. Where did he just play? He played at 1, 2, 3, 4, 5, 7. He just played there, and they're supposed to play here. And I output 8, 5, 0, 1, 2, 3, 4. Oh, and I already played there before. Well, I already played there before. That must be my get best move. Also has that same basic issue, get best move score. Same thing here. This is a score here. Don't let him play in these bad moves. So this is i32 min value, because it's not filtering out the ones that are occupied. Uh-oh. Tempted to overflow. Oh shit, we can't though, because in this case, we're adding to them, so that was bad. So we're going to actually have to filter it here. Dot map t0 map dot. We'll do a filter down here. Filter cell, score. And we want to say, what is filter supposed to return? The things that are valid? Yeah. Closed. And one cell equals 0. Dot max by key. well, I've got something wrong here. Expected closure that takes one argument. Oh yeah. Syntax overload. Syntax overload on your way. And just random shit with the ands again. Who knows? Again, this is... I honestly don't... Unless I memorize these damn things, there's no way for me to know whether I'm supposed to put an and here or an and here. There's just no way. I'd have to memorize the signature for every single one of these functions and understand that based on the parameters, the signature changes. Alright, so this is why this testing is really bad. I'd really like to test it locally, and we'll get there after we get this done. If we actually get this working here, we'll then figure out a way to test locally. And so now we've won, which is a good sign. We've picked a good score. And I don't know how we won. It looked kind of random. Let's play that again. Let's play another one. We might have to evaluate those type words a lot quicker. Well, we're just not doing a deep enough evaluation. Well, let's put some output here. What do we put in pre-line? We don't need that. We know that's working now. And get best move score, get best move score. Let's return to score SB cell. This was score. And I actually want to see the score now. Print line. Best score, because this should be a very high value or a score. See that it's actually working. And instead of doing 10, 10 is like virtually nothing. Let's do 100. Let's see what we can get away with. If we can't get away with 100, we're in trouble. Or we're doing something wrong, but I don't think so anymore. So let's play a game. That's bad. That's really bad. Getting a whole bunch of zeros for best score, which is bad. Okay, so we're going to have to test this locally because I can't figure out what's going on here in this game. And what we could do is play a random game down to 50 and then score it down. Because it shouldn't be 0. 0 is something horribly wrong. Let me take a quick break, like 2 minutes, and then I'll be back and we can figure out locally what's going wrong here. Because it looks like it's still basically just random, and then we'll figure that one out. Just give me 2 minutes. All right, let's figure out what's going on, and we're going to do this locally instead, because we're going to have to debug this. I'm going to make another version of play, and play is... I don't know how I want to do play now. I want play to make actually player 0 always win in play. And so we're going to make a variation of play. Play to end. And we don't really need to call play to end anymore. We're going to make one that plays less than that. So play to end, what does it do? We could modify this, but we want this to be fast as well. So let's just start copying this function. I mean, it's not that great. Play steps. And the current force, we'll let it do... Okay, and then we're going to say count steps as I32. It's mutables. No, it doesn't. Yeah, okay. Let mut remain equals steps. If remain is less than or equal to 0, then we break. We're done. We don't want to do anything then. Then we're going to return game result open. Game result open. Now this is a bit weird because we have to return the force step. We have to say what the next player has to do. Well, that's going to be a bit weird. So it's going to have to be a game result combined with a force. Game result open, comma, force. So it knows how to continue. And it's going to remain minus equals 1. And so this means it always takes one step. Otherwise, this here is going to be R, comma, and that doesn't matter what the board index is, board index none in this case. So play steps is going to play a random game up until a certain point, up until a number of steps. And there should be an equal number so we know a player. So let result, comma, force equal play steps. Mutable board, we're going to say player 0, current force is none, and we have to do an equal number. This is a bit unsafe because so each person takes the same return, so it starts at player 0. Let's let them take each 20 turns. That might be too many. And then we're going to print out the board. And if result equals game result, or just not equal game result open, well, this kind of sucks because it means the game finished early. Oops, early win. And that shouldn't happen. 20 random moves. We might have to reach number, but we're just going to return here. Just get rid of this. I'm going to print the board off. We'll print the board in any case. Okay, now we have to do... We want to do a different play to end. And again, I need to copy it because I don't know how yet in Rust how to vary this stuff that much. Play to win. We're going to do a play to win, which takes the state and current player and the current force and returns a game result. And the difference here is going to be this get random move here is going to be if player equals 0. We're going to make player 1 win. Then get best move and state, comma, player, comma, force. Else get random moves. So the other player is just going to take random moves and we're going to take the best move. So we test this locally, and I said I don't know how to combine this logic. There's a similar pattern to this stuff here, and I don't quite see it how to do it. So we'll figure it out though. We'll just let it go this way. Result equals play to win and mut s.board player 0, and we have the force from before. So now this should be enough to do clear and cargo build. Now we have errors. Expected tuple. Not so many errors though. Don't use that score. I wonder if that's a problem. No, it's fine. 35. If player so. If and else have incompatible types. Well, no, they don't. Oh yeah, because that has no type. Okay, so now we have targets. Targets, debug, play. Okay, and 0 wins, which is what we expected. He's supposed to be winning. We have all these best scores 0, which is a problem though. So there's something wrong with the best score here or there. And actually, can I just split this window off here for a second? No, I should really just use a different window because I want to switch back and forth. Because this window here kind of sucks. Go back to this. I'll just make this window smaller so we can see it. cd/source/evening rust private. I think I can increase the font size here. CD tic-tac-toe will do target/debug/play. We can do a clear here. So it's a bit easier to see this thing now. I mean, 0 always wins, but it's that best 0 score that's bugging me. I don't know why I always see a bit there, though. Okay, so this best score, there's something wrong with that. So we got to figure out what that is now, first of all. Oh, scratch my eye, sorry. We do get best move and best score. Now it obviously finds something of worthwhile. And, oh crap, I forgot this. Tree I equals CS. I forgot to set the value back into the tree. So cargo build and clear and tree is not mutable. Okay, 0 wins, and now we should see some scores, best scores. And so the scores are kind of random, and it gets 10's pretty good, though, for a score. There's a bunch of 10, so it's always going to be picking whatever that 10 score is. It'll pick the highest one. And 0 should always win now. I mean, we may not go deep enough, but near the end of the game, it should be easier for it to figure out it wins. So now we play. And we lose. Why do we lose? We may not be looking deep enough. Well, because the boss is not doing random. Okay. Now, the reason why we're probably losing now is because our evaluation of the game is incorrect. We've forgotten to consider the case, and I didn't realize I'd come to this so quickly that when the either board ties, or he actually won here. Well, shit, that's weird. He actually won there. Let's play this again. We should have found that. Unless we're not going deep enough. We'll find we win there, and I'm going to speed this stuff up a bit. We don't need... Oh, it's already fast. I just do 5 times. Okay. Best score is always... Best score can only be 10, of course. And that's near the end, because that would mean absolutely everything we evaluated was a 10. But at only 10 evaluations, we may be getting forced in a situation where we lose. Well, let's submit this and see how he is. Maybe we win enough of them to move on. But 10 is really not very deep. 10 is like a really bad number. I mean, like 10 evaluations per position is really not enough to guess where we should be going. Near the end of the game, when there's guaranteed wins, we should be able to find the guaranteed wins, but we won't see much more than that. And let's see how far this gets us. We are already at 15 without any strategy, so it may be just enough to get out of this league. Alright, like so far it's looking pretty good here. Now, we haven't actually done the proper Monte-Carlo tree yet. We've done a simple evaluation. It's just a simple, this is not actual a tree yet. The tree will come later as we actually need to get to it. And, well, technically we have a tree. We just don't retain the tree. And what will happen is when we retain the tree is that you can reuse parts of the tree when you go to the future rounds. So if you predict 9 branches of the tree, and then you pick the one, and you also predict the other player's turn, you can walk through it. Then if you take his one, then you have at least a few iterations. But doing only 10 iterations, there's no value in retaining the tree anyways. There's just nothing left there. There will be no moves left. And so some people have a strategy here, of course. That's what we expect. And, well, we're probably doing well enough anyways. Let's just see if we slip into the next round. We can work a bit further on that anyways. My concern was that, you notice when we put the number to 100, that we already started failing. That's a really bad sign about the speed. We have to be able to iterate thousands at least, not tens. We have to iterate thousands, not tens. And did we just drop back down? Oh, some people have a strategy. And so we haven't evaluated many gourds yet. Oh, that hopped us up a lot. I don't know how the boss plays on this one. I don't know if he has a strategy or not. And I really don't know, so I really don't know how hard good. It can't be that hard. He must just be like looking for individual small boards. And there's probably lots of people in this league too still taking the heuristics approach, which is a good way to get started if you don't know what other way you want to take. That's how we did the superhero competition, was strictly heuristics, no valuation. But here we want to do valuation. We get up to 4. Come on, it has to go up just a little bit. And like I said, I can simply increase that number, but if we're actually timing out, then I can't increase it. If we're timing out by increasing it to 100, I'd say we have a serious problem. We need to evaluate at least 1 million per round. And 1 million may sound like a lot to play to the end, but that's at 80 moves. That's 80 million operations. And even if each operation, yeah, that should be fine, right? Because we should have, even if each one takes 100, that's still only 800 million operations, which still gives you a buffer room of 10. But in debug mode, we might have an issue. So these guys are going up, and our score keeps going up. So we'll probably get to the next round. So let's just let this run into the next round for now, and we'll see what happens there. And then we'll have to start doing some benchmarking and where we can speed it up. But I really fear it's that get random move, which is the issue, because we don't have a good algorithm there. The get random move is doing some weird looping and shit that we don't really like. And we'll have to speed that up, and then we'll have to do benchmarking to see how long this takes to get the best move. We'll calculate that one function, and we do that. We don't have to do that in a benchmark. We just do timing in the one code because it's not a true benchmark, but we might not actually make it with this because there's enough people pushing the boss up, and we don't beat the boss all the time. So let's just let that run for a second. And so like I say, the option here is to increase this number here. So 100, this really has to work with 100. And I can just go to the other screen actually. A moderated seal. And see, we actually get to 100. See, this is the type of thing you want to see, and this is really great. And so this took like basically, and this is really sad, it played to this, is that it started from a losing position. It started from the position saying, look, my best move is that he wins 12 times. And then it slowly worked its way up until basically it got to a position where it always wins. And because we're starting with a random board that happens. And this time we started the random board good. We'll max out at 100. As long as this number is positive, we're assuming we can win the game still. But you see the randomness here can still bite you in the ass. That, look, his random move screwed us up. But obviously player 0 is always winning. And 20 steps into the game is pretty extreme. Let's take a look at the board again just to make sure we're at rank 2. Oh yeah, we'll probably see what happens there. So we're still going up. We should probably make this. We have half our battles left if we keep going up. And like I say, we have to make that deeper and see how far we can go. But at 100, you notice it was timing out in the game here. Yeah, and this really sucks. Like, this is a problem to, like, a level. I was assuming we'd start timing out at, like, 1,000, not at 100. But even at 1,000, I was actually hoping to get to 10,000. If we're timing out at 100, we're basically screwed. I mean, there's no amount. I mean, there's lots of pruning and stuff we can do, but if we can't do that 100 loop, there's nothing you can do. You can't make it further, because you have to be able to do thousands of iterations. And if we can't do thousands, and so we're way up the top. So, like, I mean, we clear the bronze level fine. We get by no problem. And can we at least do 20? No. God damn it. Can we do 15? I really can't believe it's taking that long. Oh, wait. You know, I have to rebuild that. Dumb me. Right, so 20 works, and we get that, and we're ranked number 1. That would give us a better score. Let's put it up to 50. Can we actually do 50? Right, and if you don't want to build a clever Monte-Carlo, if you have resources to burn and you don't want to go beyond this, you just keep increasing this number. And then you can avoid all cleverness. And I'm willing to bet the guy doing C++ at the top, this is all he's done. Just build the damn thing in release mode, put this number up to 50,000, and just go. And you don't need any cleverness. But if we can't get to even 100, our cleverness won't help us. Did I actually build this? Let's see if this can actually build this way. And no, we're screwed. Invalid output. Okay, so we have an issue here. You know, maybe we are doing wrong output somewhere, but I doubt it. It's down to 40, but that almost works. So there's like some weird blip, and that blip coming at the end doesn't make sense because near the end there's less games to play. And we're going to actually probably have to do trimming it down because at the beginning, in the longer branches, you can't do as much, and we'll have to actually make this time-based. I just want to see how much I can get away with originally. But it has to be time-based. You run until you're out of time. Okay, and that should be good there. And yeah, we're doing fine right here. We're past the boss, and we'll beat him probably. It's pretty close, and it's because our depth isn't very far. But we should be enough to get by, and then we'll be, I don't know where we'll be in the next league, not very high, but then we can submit the one that we have with 40 and see how high that gets us. But again, with this approach here, and this is not a tree-based, this is technically a tree-based Monte Carlo, but really not a good one so far. It's really just the brute force kind of look. It's not brute force, it's like a random sampling of the games to the end. Just pick the branch that's good and move on. And we've not done any of the sort of heuristics tests to look at the ones that are winning and looking at the confidence values and preserving the tree or anything like that. Alright, so we'll make it to the next league. I think that's what little bum thing probably said. Yeah. So we'll go to Silver League, and we'll go to Silver League, and... Seriously? 22 minutes? What the hell? That can't be right. Well, this is weird. I've never seen this before. This looks like it's broken. We've never had more than like a few minutes wait. This is a 23-minute wait to make it to the next thing? Well, then let's work on our things below. Let's work on the benchmark. Let's see how long this actually takes. Let's see how it takes to get the current time here. Okay, so why are the numbers so high, Euler? I mean, 6 hours. Is there a reason they have like really high numbers for this? I mean, I've been used to so far it only being a couple of minutes. It just seems really weird that the numbers are so high. Well, we're probably just going to keep going up here. I mean, let's time our stuff. Let's see how we get the current time in Rust. Rust, performance counters. Nothing on the official Rust. Rust, get current time. How do you get the current time in milliseconds? I want something closer than milliseconds. Time now. Well, I guess the game works in milliseconds. Should be fine. Instant. We're going to use standard time instant. Winter Squirrel, so you're saying they want to keep it competitive for a while? Or is it like... Well, yeah, with people sitting up here, I mean, it's certainly going to make it competitive, because if you are better than the boss, like if you have a whole bunch of people up here, that makes it really hard for the guys at the bottom to get higher. Because the moment you get up here, you're going to compete with a bunch of people that are better than the boss. And that's going to drive your score down. But at this point, can I actually not make it anymore? Like, if I get pushed below the boss, do I get excluded from promotion? Or am I guaranteed to be promoted at this point? Clean my glasses. I can't touch them somehow. So if I can... I'm curious about that. I'd actually like to see myself go below the boss again to see what happens. You are okay. So it's just really just a timing thing. And it's just here, so people still in this league have to fight with people that are actually in the next league. All right, so this Patata here, he's clearly got a much better strategy. I didn't clean my glasses well. But again, ours... can I submit again? So if I want to beat the boss, you should submit right after promotion. Can I submit again now? Go for it. Let's submit. Wait, I improved mine though. Won't that make it worse for the other people? I'm concerned that I'm losing more. There's no way I change my code to lose stuff. Well, we'll see what happens here. We're going to have to do time. I just want to see where I get with this anyways. Let's see where we get with this one here. Yeah, Patata here is clearly... like I say, in C++, you could have the exact same code we did, compile the release mode, more efficient, and just increase that number that I have at 40 to literally like 10,000 or something. It really doesn't take long to evaluate tic-tac-toe, and we're going to have to figure out why we're so slow. Obviously, we're in debug mode, but that shouldn't be that bad. But if it is that bad, then we go play a different game. And if this doesn't go up as high, it means I'm timing out still. Moderate, so there's no way I can actually do that, I think. There's, what's his name? Patata. Let's do Patata instead. He's stronger than us. Hello, Patata. Let's play against you. Well, I beat him once. All right. Well, this is weird. Oh, we tied. Wow, an actual tie. That is impressive. It's really hard to tie in this game. Alright, so this is his first actual win against me. And that seemed like a relatively quick win. Shit, I timed out or something. Am I stuck in the leaderboard too? 40's too high. I'm timing out. Damn it. So there's a lot of variability on their servers. Oh, this is going to be an issue. 30, I mean, seriously, 40. Alright, I won. Play again. I won. His bot can't beat me. This is really screwy. Okay, there it beat me. Hopefully not because I timed out. No, I didn't actually time out that time. Well, let's submit this one that doesn't time out as much. We'll just mess with people. But we know down to 10 we win, so anything above 10. But so that must be why we're losing, because we're timing out. And we still could be timing out now. It's really, I mean, there's a bit of randomness in the timing. Well, I don't have any timing yet, moderated seal. I'm just putting a fixed number in because I haven't put my timing code in yet. But we'll actually have to put timing code in there so that we actually play the maximum amount of time we have. But as I said, that's my actual concern, is that if this number is 30, well, Monte-Carlo doesn't work at this amount. Monte-Carlo requires lots of iterations. And 30 is not lots. 30 is nothing. 30 is just like rolling a die and picking a random thing. Because this is at most, times non-board cell, 270 random games. And like, woo, I mean, that's nothing. That's absolutely nothing for it to play. And near the end of the game, it can evaluate more because it's not as deep. So we will have to alter the depth as the time goes on, but we'll see. Maybe it is just too, I mean, 80 moves shouldn't take long to play. It's the valuations maybe too long. We have to figure out what that is, and let's see where we are now. We're still going up here. I said we're going to time this now then, right? How do I get the current time? Standard time instant. opaque and useful only with duration. I'm fine with that. I'm fine with that. So let's go set up our play thing here. And the play to win, right after we run this random game here, actually right at the start too, we're going to do a let n equal standard time instant now. And then we're going to print line here, elapsed. And the game measures in milliseconds. What's that? What am I looking at? Global. These are just going games, yeah. Okay, Coda Strike Back is different. Coda Strike Back you can use a lot of heuristics on, because that's the game like that. And so there are heuristics, but a game like tic-tac-toe, you're probably not going to want to use heuristics. I mean, we can use them to speed it up, but I really wanted just to use the Monte-Carlo because it's a simple enough game that it should work, and even mention it in the description that you should be doing it, so it has to work somehow. Yeah, and I say, even with prediction and stuff, doing turns, there's a lot of ways to do it, and so Minimax is good. But once you enter the realm of Monte-Carlo, Monte-Carlo is like the one, and we knew this going into it, that Monte-Carlo is the one that says, hey, you got to do thousands of iterations. Thousands upon thousands upon thousands of things, because Monte-Carlo is pretending to be dumb. It's like, you're not supposed to use heuristics. Just evaluate the tree. And I mean, we're supposed to be doing tree pruning. Our tree's not very good yet, but at 30 iterations, there's nothing to prune and nothing to improve. Now dot elapsed dot as, what can I say, as milliseconds? And you're only, what are you using Euler? You're only getting 300. Yeah, 300 is also, it's just not enough. You just can't do it. I mean, it's too slow. Are you stuck in debug mode as well, or? Ugh. Elapsed. What does elapsed return a duration? C#, okay. Yeah, but except C++, because C++ is the one that lets you turn on a pragma in the language that forces you into release mode. So I think C++ is the one where you can basically cheat. You can basically say pragma, turn on debug. And languages differ in terms of their performance in debug mode. As we've seen with Rust, Rust performs absolutely horribly in debug mode. But it appears at 300 playouts too, C#'s not doing any better there. So, and this actually surprises me. And the guy, one of the engineers, I think, on Twitter. Oh, that's true. So yeah, true. The standard functions won't be any faster. One of the coding game, I think their engineers or something actually said, or their CTO or whatever said, they're going to look at release mode, because if you're promoting games that say you should use Monte-Carlo, you have to use release mode. I mean, it's not really, it's really kind of mean to say, hey, use Monte-Carlo, but haha, debug mode. All right, so can I say as seconds, as millis? There's only as seconds. Okay, fine. As secs times 1,000. What? Subsec millis. Oh. Come on! There's no way to get millisecond duration from this in the current version? Ugh, fuck. Oh, nano. Nano is good. That's fine. Let's just do nanoseconds. Nano's not part of the subsec nanos. The fractional part. What? Geez, why can't they just build a normal time API? Something that returns a floating point fractional amount for seconds. This is like the most retarded API I've seen for instant before. You're supposed to have one function. The one most important function is missing. The one that returns a floating point value for the number of seconds that has passed. k.assex times 1,000, just in case it takes a second, plus now. No, we need an elapsed, like e equals. So this just makes it hard to use this thing. Now the elapsed e.assex plus e.subsex. Subsec nanos. And what is subsec nanos returning? A U32. Killing me. .0. I think I do 0.0 subsex F64 from e.subsec nanos times 1e to the minus 9 and minus 6 because I want no, not gonna second. So I had to do something here now. Where are we standing in the board anyways? Wow, we're timing out still. Shit, that's a problem. That's terrible. So I can't even get 300 right now, 300 playouts. Alright, let's see how long one takes at least. Get best move. Actually, I already had that over there. I don't want to ignore that. I need to actually iterate it. Q, we'll just do this here. So we can't get rid of it. We don't have the black box. I'm going to say and s.board for player 0. And no, get best move. I want get best move, forced index, yeah. Just get best move. Board index, none. Okay. We don't have to care what that value is. So let's see if we can actually do cargo clear and cargo build and target /debug/play. Not found in the scope. Cannot find value now. Oh yeah, that makes sense. It's because I call it n. And this is why I don't use the from, because the moment you try to use from, it just gets mad at you. Lesson learned, just always do as. Either way is lossy, so. Now, how long did this take? 441 milliseconds. Well, that's bad. That's really bad. So let's see how long it takes again, if we do it again. 439 milliseconds, and that's if you have up to 30. So that's why we're timing out, because that's too high. For curiosity, build-release. Let's see how fast this goes in release mode. I don't know what it's compiling or why it's taking so long, but so in 2 minutes we go to the next mode, so we're not going to get a chance to submit again. That's fine. See, this makes more sense, 27 milliseconds. But this is what I was expecting of debug mode. So it's 20 times slower, and this is in line with what we saw before, and we've not optimized the code yet, but 20 times slower is a huge difference. Because at 20 times slower, it means you can bump this number up to 300. And see what happens. It seemed to go fast there as well. So it took 259 mils, so not quite so high, but you can see the scores now. It's getting like absolute certainty. Basically, the higher you put this, the better chance you have of going up. But, so we had said 15 might be the limit, but we're going to have to put timing in there because the initial few turns, as we get deeper down in the tree, it's faster and faster to evaluate a game. Wait, now I gotta go back to debug mode. Right, because the initial game takes the longest, so the initial games we're gonna have to use more heuristics, sub-heuristics, and stuff like that. And I already knew that going in, but near the end we should be able to get up to more. And I can't believe it takes 220 milliseconds, so I'm still probably at 20, at 15. Alright, so we're gonna have to find a time limiter in here for the next round, so at least we don't time out. And unfortunately, it's kind of annoying that the duration in Rust is kind of shit to use. It doesn't have a decent interface, so I'm going to have to make my own somehow. But I guess we don't have to because we're never going to have a whole second, so we can just check the sub-seconds. So we put the timing right into the functions then. And this get best move score is going to have a time limit that it has in it. Count equals close dot count zeros count. Oh, I gotta figure out. So we went to the next league, and we're gonna start failing in the next league. So we're in silver. We're still connected, I think. We're not at 30, obviously. Let's get rid of this first. Let's put us back down to 10, what we had before, and just submit it. Let's see how far we get in that mode. Cargo build. Let's just see how far we get in this mode with that. And then we'll start putting the timing in our code so it's at least dynamic. And we have get closed mask. And this is the one here. I'm trying to figure out how many board cells. We have to count the number of cells, ones that are open. And closed or, and I just got to fill this up a bit. X, FF, FF. That's a U16 shifted 9. I got to make sure that all the top ones are filled in so we get a correct count here. Count zeros. And the count zeros are all the ones we have. And so the get best move score, we're going to have to say how much time does it have? Well, let's give it 90 milliseconds. So we're going to put this in 90. 90 divided by count. This is how many milliseconds. And we'll say I32 from count. How many milliseconds does this one have to perform its move? And we'll put it right down here. millisecond timeout. Milliseconds time is 932 for some reason. We'll let n equal standard time instant. Okay, and every iteration of this we can check this. We check that well enough. So we don't have this now. We have a loop. And we're going to say if e dot subsec nanos. Oh wait, n dot elapsed subsec. We can't use micros because it's part of an experimental thing, so I can't use it yet. Times 1e minus 6, and this is an F60 as F64. I really like the millisecond one now as well, but it's not there. Well, let's try it. Let's see if it's there first. Subsec millis is greater than or equal to ms time. Then we break. We stop when we get that time, and we have a buffer there anyways. Let's see if this actually works. Use of undeclared typer module standard. What do I call this? Standard time. Use standard. Use standard then. What the hell? Why is it working here and not over there? Standard time. Oh, because it's probably now. 49. Now. Convert from. Again, I tried to use the from function. That just doesn't like me. Where'd I put that? I32 from count from U32 as I32. Oh, so it's already complaining right here. I can't use it right there, so fine. And subsecond nanos divided by 1e6 then. Is this going to complain that this is a floating point number? Yeah, it's going to complain this is a floating point number. I really don't like programming languages. Just because I have scientific notation doesn't mean it's a floating point number. Expected U32 found I32. Well, let's just make this U32 then. It's a timeout there if it wants to get that. Alright, so this should do a number of iterations each time. And I want to track the iteration count. Let mut iter equals 0. And right in here we're going to do iter plus equals 1. And eprint line iter. And you know what I should do, and you know what's really screwing me up, is I'm printing out the board every time, and that's going to slow us down. Ah, I got to think of that. Iter. So let's get rid of these, because that printing the board is actually slow. But I mean, we just do it once, but still formatting, I don't know. Let's get rid of, no, not here, it's an entry. Let's get rid of the board printing each time. Let's get rid of this. Okay, and so we've made it a little way up the ladder. I'm guessing I'm failing there anyways, though. What's around me? So we're still going up, but we can probably do better than that. Let's see if this actually plays as a default AI, how many moves we do. The default probably no good, though. We have to go choose a player. So you can see as we get closer to the end of the game, we get to do more iterations, and that's because the tree's not as deep. But it looks to be okay. And when we have multiple options, this is the worst case. When the game's actually open, this is the one case where I might think, well, maybe we should do a heuristic here. And what I mean by that is when the board's open, when we can choose any of these spots, what we should actually do, maybe this helps, is run a miniature evaluation on the big board to choose which small cell, and then inside that cell choose that, because doing the big board is too many branches, and that's one of the options we have for optimizing this. But the thing is, that's not guaranteed to be the best strategy, because it's quite possible that the best option on the big board isn't necessarily the best overall game option. But let's submit this, and so you can see right at the start, 63 on each of the big ones. That's not a lot of iterations, and so that's effectively choosing randomly at that amount. We're going to resubmit this and see if we can actually, I just don't want to time out now, and see if we get far enough. And, well, initial battles look fine, of course. Oh, our friend in coin, haha, back and forth. So it must be who started the game. So we must always play in pairs of 2. That makes sense. You always have to play 2 because some guy has to start, and the game isn't valid for that game. And so in Koyan, I mean, you don't have to actually analyze the ones where it's like that. It's the ones like this that are most problematic. I mean, we lost against the same guy twice, regardless of whether we started or not. And so what do the leagues go up to now? Did they open the other league yet? Oh, there's still no open silver league. It's still silver. And let's make sure we haven't timed out anywhere. It looks like we probably don't, but there we did. So let's take this guy. Who is this guy? Jay Bentz. Let's play against Jay Bentz. He seems like a random guy. We lose against him. And just to sub Jay Bentz, is he near the top? No, he's not. Jay Bentz. Well, he's at 30th. So let's play against Jay Bentz. And we'll just see what the iteration count. I just want to make sure I'm not timing out or doing something stupid. And he looks to be about the same level. We're at 40. And Jay Bentz won, and we're doing 1,200. See, this is numbers too low. So 1,200 iterations near the end of the game, and we still made a move that let him win. Right, and this is the thing, is that we might want to do a heuristic on checking the insane conditions. Because look at this right here. We can quickly look at the board and say, if he plays here, he wins. And this is one of the failures of Monte-Carlo, is that, well, if I don't happen to evaluate that position, I don't see that. Right, so when I'm on this board here, this middle button here, this middle spot here should be an absolute no-no. Right, because this is an immediate loss. Now the question is, how can I check that quickly in the game? Is there any very quick position that's an immediate loss? And this is where the 2-level tree comes in. What now is I'm doing 1 level and then doing everything randomly. And that's insane. That's not enough. And the tree actually says what I should do is I should, at least for the alternate player, check all of his moves as well. Because in this case here, I would immediately see, if I did the ultimate player, the alternate player, I would immediately see choosing this middle thing is wrong. Because if I do all evaluations of the other player and he has a win, then it's terrible. Or maybe I'm just not valuing them correctly. Aha. That's actually a good point. I have a scoring issue. When I go and play middle one here, and I evaluate all his moves, wins and losses, I have to make sure that if there is a win, that dominates. So I'm not adding up the scores correctly right now. I don't know if you understand what I'm saying, because basically right now, if I play here and evaluate a whole bunch of moves here, The reason I say I'm not adding them up correctly is because if he plays here and wins, and the game wins, this is his move. If he wins on his move, and he gets the choice, then that's like an absolute bad branch. It's not a branch, it's an absolute bad branch because it means he wins immediately. But it's because it's only one move that makes it hard. And so I really have to check there what happens. I have to see, again, if I just evaluate all of them. But look, we're still doing quite well here. So we're all competing with that. And we're all competing with debug mode. And we're not doing so bad. Can I improve it just a slight bit, though? That'll be the question. Without doing too many heuristics, can I improve it just a slight bit? To look for that immediate win one. We know we're not checking ties right now either. Ties we're just kind of ignoring and letting the game play out. So we actually have an error there. And I'm just trying to think of the situation we had right with Jay Bence, whether I can actually detect that quickly. And we're going to have to do a min-max on that as well, but we don't have the time for that. What I mean by min-max as well is that when I pick a move here, logically what you'd pick here is let him do evaluation as well and then pick his best move. But this is where the tree is going to come from. And this is what the Monte Carlo tree actually does, is the moment you've identified a winning move here, for him, in the min-max strategy for the Monte Carlo tree, you're going to say, well, look, there's a winning branch here. So every time you get down here, don't do random. Do the best move for him. And this is going to bias it strong towards his best moves. And you're going to realize, hey, look, he's always winning down here. This is a bad move to do. Similarly, when we find branches of our own that we win, we explore them more often. And this is where the actual Monte Carlo comes in, is that you actually start... You don't just do randomness at each branch level, you start basing it on your confidence and how many times you win. And the places where he wins the most on his turn, you evaluate more. And the places where we win the most on our turn, we evaluate more, because we want to go down that, and that's basically a min-max strategy. And that would probably get us quite far, but the only issue is time. They start taking a lot of time. And again, not a lot of time in release mode. In debug mode, it takes time, but that would actually spare us a lot because it means you don't have to go as deep. I assume these guys at the top, like, yeah, C++, 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 C++. There's Java up there, though, which makes good hopes. But Java is going to do runtime optimization in debug mode as well. And where are we? Yeah, we're down here. That's a pretty big spread to the top. I just wonder how much I don't know how much I want to do tomorrow today, because it's going to start something entirely new to do the branches. I got the basic Monte Carlo done. It's not a competition stream, so I don't want to spend hours per day. I just want to see this one play out. We'll probably be stuck at 20. And that just plays the maximum times. Just play another game with Jay Bence and see why we lose again, to see if my one condition would. But he's already looked deeper. I mean, even if you fail, even if you screw up the last move, it's stupid, but you've already screwed up the game to get him to that point. All right, and this is one of the ones I either said. Look at this. When we have no options left, we can evaluate 29,000 games. Yay, no options left. Alright, but let's do something. We could actually, there's one fix we can do really quickly, because I know one place where it's probably slow. And do around me. So we're pretty much stuck at this level at 20 where we are now. But there is one place we know where something is slow. And so how long are these games taking? Let's do play again. Let's optimize this output to see. Let's get rid of the board printing. We just want to see the time that comes out. Who wins in board print? And we gotta get rid of those iter counts as well. Those iter counts cost us time, but well, no, we actually want to see if we go up. Elapse 100. That makes sense. We went slightly over. We don't actually have to print that now. And we're going to do play to do right from the start. Play steps, we're going to do 0. Don't play any steps. And so basically we get 63 moves, or 54, 63. These are the numbers we want to beat. So these are our basic optimizations, 64, 53. And anything we do should increase this number of iterations we get. And this stays that way a long time, so we don't get very many iterations through before we get to the end. And we can look for places that are actually slowing us down. Anything in strategy slowing us down? Probably not. There's not a lot I can simplify this through. This loop here, this checking here, you shouldn't do this every loop. But my fear is that we're so tight, I have to check this every loop. These functions can be notoriously slow, but it's probably this stuff down here, which is a lot longer. So play to end is really... Cloning I don't think is a big issue. Cloning takes no time. Take turn. And what can we speed up here? Nothing here. Let's check the one function which I think is slow, random free. So random free is the one that I think is really slow. And we're going to try and speed up random free to get rid of bit counting and everything. We don't know if their index has fast bit counting. This random number generator, grabbing this actually takes a bit of time as well. And we're going to say let's say mut free equals range dot gen range 0, comma board num cells. As use size probably, or as use 16. Now what we're going to do here is this. We assume there is one free. So now we're going to say if. We have to get this use still, so this use comes out up here. These are all the used ones. And I'm hoping this is relatively free even in debug mode. If this is if these index looks up are costing something in debug mode, we're in trouble, but these are constant, so I'm hoping this is compiling really quickly there as well. If used and one free equals 0, then we return free. Otherwise we say free equals free plus 1 mod board num cells. So this is a lot simpler algorithm. We just pick a random one and then find the one after it. It's not as fair, maybe? I don't know. We'll find out. But I'm hoping that's simpler enough to see if it actually makes a difference in speed. Because we're at 54, 63 iterations near the top. And we'll see if we get... oh yeah, because that was close at the bottom. Oh, come on. Expected use size. Oh yeah, okay, so free is then use size. Fine, use size. This also actually bugs me about Rust, is that really, come on! A U16 becomes use size, no problem. Just convert this to use size. It bought us nothing. and bought us absolutely nothing. Who calls random free? Get random move, and we could pass the random number generator down. Well, let's try something crazy first of all. I have to know if this is hurting us. Oops, I closed the wrong file. We're going to say n.elapsed subsec. I want to see if this is costing us something to call that function. Oh, come on. Oh, I copied the wrong thing. And we'll print out free as well, just to make sure it's not ignored. So let's see how much randomness is costing us, because we can fake randomness if randomness is going to cost us money. I hope that's a joke. Does everybody else see this number here? That's like a cruel joke. Is it seriously taking 500 microseconds to generate a random number? No, it can't be. That must be the thread RNG lookup here. I'm going to run it again first just to make sure it's not crazy like that. 360, Jesus Christ. 400 microseconds to generate a random number. That's ridiculous. Let's see if it's all this lookup time. This probably has locking and stuff, so let's generate the part where it says just the random number. Okay, 2 microseconds still sucks. Come on, 2 microseconds is shitty, but maybe it's debug mode. Okay, but this would confirm that we had in the last game that this thread RNG is absolutely awful. And that could be killing us right now. We could pass it along, or we can try to make it global. And I want to check in debug in release mode though, first of all. So our numbers are a lot higher here, and 630, holy. All right, guys, Rust's random number generator sucks. We can't use it. 613 nanoseconds to generate a random number in release mode. What is it doing? Is there like a fast random number? This is like, that's total crap. So we're going to probably build our own. But let's use the global one first, because the biggest thing is the lookup here. The lookup is what's killing us the most. So let's get rid of that first of all. And I want to look at how do I create a global in Rust. A global mutable. That's something with ref cell or something. I hate these non-answers. Lazy static, do array, unwrap. It's not helping me. This is not helping me. It's got to be global. I don't want to pass this shit around. Global variables have a place in programming, and there has to be a way to do it. Global mutable. Come on, let me do a row mutable. There has to be a way. I can't believe there's not a way to do a global mutable. It's a totally normal pattern to have singletons. Oops. Oh man, I hate their book. Their book sucks because if you try to click in the empty space, it goes to the next page. Static variable, static. Okay, so we gotta figure out how to do this. I don't care, I don't need a did race. Well, let's see if we can do it. It's static. State. Static. And thread RNG. I don't even know what these things are called. That's a problem. Doesn't exist. What does this return? A thread RNG. And we want to have global RNG as a thread R. No, it's not a thread RNG. I don't care what it is. It's just a. How do I create RNGs? What are these things? Standard RNG? Is there a fast RNG? That's what I want, small RNG. Yeah, I don't need cryptography. Static mode global strategy is a small RNG. Small RNG new. Let's see if this works at least. A small RNG. No small RNG. Oh, come on. How do I import this stuff? It's not there. First of all, what did I screw up there? No small RNG in the root. What does that mean? I don't even know what that means, to be honest. Let's put it down there. Why can't it find these things? Why are they not there? Anybody know Rust? Know why I can't use small RNG? Something funny. Well, that didn't help. No in the root. Let's just do no in the root. See what that means. No. So I don't know what's going wrong here. How do I create a small RNG? Why is it bitching at me? Unresolved import. What does that mean? Rand. I don't understand why it doesn't work. The docs give no indication of version or something. Well, this is the same error message. Well, I have it in the TOML file, though. Rand equals star. It's not helpful. I don't get it. So now I'm stuck by Rust again. They're not found, so small RNG must not exist. We just have to. I don't know what version it is, but it just doesn't exist. Where I have no idea what these docs are for, but small RNG does not appear to exist. What other RNGs do I have? Let's try any of them. Standard RNG. Well, standard RNG, so small RNG must not exist yet. Is there a fast one? I just want a fast one. But it's very fast. Zor shift sounds good. Let's see if that exists. Well, Zor shift exists, so let's do a Zor shift. Zor shift. Zor, okay, how do I use it? New unseated. Well, that sucks. I don't want new unseated. Seedable RNG. How do I do a seedable RNG? I don't get how this works. Anybody know how to create a seeded RNG from seed? Aha, from seed. From range. Can we do this? From seed, and then do a... Where's that thread RNG? From this thing. From range. From random generator. No, from RNG. What's it called? From RNG. It says from RNG. What's its problem? Was it supposed to be... I don't know, from seed 0 then maybe. Well, we have to use seedable. Well, let's go back to the other one then. From RNG. Oh, piss off. So that doesn't work. So we do from... Just do new. It's not as 0. I don't care. No! The hell is your problem? Docs, people, docs. I don't need the theory of the thing. I just need an example of how to use it. Rust, Zor Shift RNG, Zor Shift RNG. Maybe somebody has that. Seedable. Let's see. Anything. Anybody have an example? Anybody have an example? These are the same docs. No examples. No examples. New unseated, is that what it is? New unseated. I don't care if our program works the same every time. Calls and statics are limited to struct and enum call. Come on. This is going to kill my performance again. And the reference to it. Let's see what happens. Global RNG equals sum. Global RNG.unwrap. this. It's none. Static. Expected reference. Ah, simple things, people. Simple things. What's going on here? Expected reference found struct. And this. Static, well, I don't know, just type in shit until it works. Expected mutable reference if is none. I don't know what I'm doing. I just want to get a global static. Come on. There's got to be a way to do this. What is this even referring to? Expected mutable reference found nothing. It's not supposed to expect anything here. Let's not confuse it. Differs type and mutability, fine, and mut. Cannot move out of I'm not trying to move out of the static item. Here's some minimal static. Give me one example of a robo, one static mutable. Come on, just one example of how to do this. Any example. Anybody have an example of how to do a static mutable in Rust? I don't have lazy static though. I can't install crates, so much for that. Well, let's just make this whole thing unsafe. Just do a whole big unsafe block. I'm not trying to move. That's why I have references, references, references. I'm not trying to move anything. Come on. So much fun sometimes, this Rust. Temporary value does not live long enough. That's why I marked it unsafe. Unwrap. Unwrap. It's an unwrap. How the hell do I get this to return correctly? I don't want a lazy static. I can't use a crate. There's no static here. I'll just keep trying for a few more minutes, but I just give up. I mean, this is critical to us that we have a global muticle because it's too slow to look up otherwise. Well, here's one right here, unsafe. None of these are helping me because it's this option here. None of them are telling me how to do this option. I want this to return a reference. Why does it have to have an and static? It's static. And why does this just not work then? Let's just say like q equal global rng.unwrap and mut and then return q. Maybe there's a difference. Temporary value does not live long enough. Why not? This owns the damn thing. Rust get reference to option. Option value. This is what I want. Just copy what this is here. What do they do here? So the option is static mut-ora-y, that's fine. And get global RNG. If it's none, I'm going to give it something. Something. Hope that works. And to get it out, match global RNG and mut. I won't even attempt to understand what the hell that means. Whoops, foo, get rid of this fooey thing up here. How do I initialize this now? It's just gonna fail on me. Come on, this is stupid. This is stupid. I don't know. It's like they've gone out of the way to create a language. It's impossible to make global statics. It's super frustrating. All I want is a damn global random number generator because that's the correct way to do it in this case because it'll be the most efficient. And there's no way to initialize this. How do I initialize this? I don't have a global static. I have to create a new one, and it's pissing me off. I'm just going to give up on it. I'm going to go send a message to the news group because I'm just wasting time here. There has to be a way to do this, and I just don't know how, and it's just pissing me off. Alright, I'm just going to give up for now. I got to figure out some way to do that because it's just wasting more time, and I'm just running through circles here trying to figure this out, and it's just kind of pointless. So, I mean, sorry about the way this ended. I mean, we're over in the coding game. We're at rank 23 in silver, and if I could have figured out this random number generator thing, we'd be higher up, and I just have to figure that out now. And we're doing pretty good. I was pretty happy about this until I attempted to optimize it, and then I got slapped by Rust again pretty hard. So I got to figure that out. I go to the user group and figure out how they do that, because that's pretty critical to make this run faster. And no, I'm not about to start passing this through every function, because that's actually a really shitty design, and that's the first thing they're going to recommend. I'm going to say, no, I don't want it. I need to have my global static. And, alright, so hopefully I'll get this done by tomorrow, and tomorrow evening I can keep going on this. Sorry I can't go further now, but I need to get the answer to that first. And thank you for watching, and we'll see you next time.